Hello everyone, in this video we are going to discuss example problems from the chapter Functions of Mathematics 1A Telugu Akademi. If you didn't watch the previous videos, the link is in the description, please watch it. Examples from the page number 22. Function is defined by f of x is equals to under root a square minus x square with the condition a is greater than 0. F of x is equals to under root a square minus x square. Then he is asking about the domain. Okay, now if we observe the question clearly, under root a square minus x square is there. So always the under root value will be positive only, no negative numbers, otherwise 0. So whatever will be there inside of the square root, that value should be always positive or 0 only. So whatever is there now inside of the square root, that is a square minus x square, value should be greater than or equals to 0. So now what I will do, I want x value only. So left side a square is there. So to remove that a square, both the sides I will write minus a square. A square minus x square as it is. Left side I am writing minus a square greater than or equals to 0 as it is. Here left side I wrote minus a square. The same I am doing to the right side also, minus a square. Now left side, if we observe clearly, here a square minus a square both will get cancelled. Then we remains with minus x square greater than or equals to minus a square. Now I would like to remove the negative symbol from both the sides. So if we remove the negative symbol, the direction will change. X square greater than or equal to symbol will become less than or equals to a square. So x square less than or equals to a square, then mod x less than or equals to a. So if mod x is less than or equals to a, then the condition will be minus a less than or equals to x less than or equals to a. So this is the domain of the given function. Next, let us check the second example from the same page number 22. Function is defined by f of x is equals to 1 by 2x plus 1. He is asking to find the domain. So it's very simple. 1 by 0 is not defined. So it means in the denominator except 0, any other number is possible or valid. So here the denominator is 2x plus 1. So that 2x plus 1 should not be equals to 0. So plus 1 I will take to another side, then it will become minus 1. So 2x not equals to minus 1. 2 also I will take to the right side now. So then it will become x should not be equals to minus 1 by 2. So it means except minus 1 by 2, every other number is possible or valid. So that we will write it as total real numbers minus 1 by 2. So from the total real number set, except this minus 1 by 2, any other number we can take in the place of domain. Now let us move to the solved problems. In the solved problems also same, they are asking only domains. Okay, now let us check one by one question then. The first function is defined by, in the solved problems, first bit, first question. Function is defined by f of x is equals to 1 divided by 6x minus x square minus 5. From the previous example only we got one clear idea that the denominator should not be equals to 0. So 6x minus x square minus 5 should not be equals to 0. So this is the quadratic function. That quadratic function I will write it in the standard form. So it means power 2 should be the front, then power 1, then power 0. So minus x square should be the first term, then plus 6x, then minus 5 should not be equals to 0. Now by splitting the middle term into two terms, I am going to find the zeros of this polynomial. Minus x square as it is. The middle term we have plus 6x. Plus 6x I am writing it as plus 5x plus 1x. Minus 5 as it is not equals to 0. Why we are doing this splitting the middle term is because we need to know the x value compulsory. Now from the first term as well as from the second term I will take out minus x common. So if we take out minus x common, we remains with x minus 5. Now from the third and fourth term I am going to take common plus 1 common, then we remains with x minus 5, which is also not equals to 0. Now here x minus 5 is there 2 times, so write it once, x minus 5 times, here minus x is there, so write it as it is, here plus 1 is there, so plus 1. This also not equals to 0. So x minus 5 into minus x plus 1 not equals to 0. Now whatever the values we should substitute in the place of x, that should not be equals to 0 at any cost. Now for example, if I take this second one minus x plus 1, if you observe clearly, in the place of x if I substitute 1, in the place of x if I substitute 1, it will become minus 1 plus 1. Minus 1 plus 1 is 0. 0 into anything is 0. But according to this, we should not get 0. So it means in the place of x, 1 I should not substitute. I should not substitute. Yeah, okay. 1 I should not substitute. So 1 I will remove. Next, here we have x minus 5. So in the place of x, if I substitute 5 minus 5, 0. Again 0 into anything is 0. So I should not substitute 5 also. So except this 1 and 5, I can substitute anything. So the domain will be r minus 1 comma 5. Next, second question. Second solved problem. The function f of x is defined as f of x is equals to 1 divided by under root x square minus a square. Under root x square minus a square. So now here also same again. This denominator should not be equals to 0, as well as it is inside of the square root, so only positive numbers are required. So x square minus a square value should be compulsory greater than 0. This x square minus a square is in the form of a square minus b square. So if we expand it, we will get x plus a into x minus a greater than 0. Now if we observe here, x plus a should be greater than 0. Otherwise x minus a greater than 0. Now x plus a is greater than 0. So it means in case in the place of x, if I substitute minus a, that will become 0. And I want this value should be greater than 0 only. So it means from minus infinity to I can substitute. From minus infinity to where? Less than minus a. So minus a we should not substitute, because if I substitute minus a in the place of x, then it will become equal to 0. But here greater than is there. We should not substitute minus a. That's why we will keep open curly bracket. Always infinity will be open only. Or is there? So union x minus a greater than 0. So in the place of x, I should not substitute plus a. So it means from a to infinity, anything I can substitute. A I should not substitute, so that's why open curly bracket. Next, let us move to the third question. The function f of x is defined by under root x plus 2 into x minus 3. Okay, now this is inside of the square root, so no negatives. So that's why x plus 2 into x minus 3 should be greater than or equal to 0. So now here 2 are there, so let us separate those two. X plus 2 greater than or equals to 0, or x minus 3 greater than or equals to 0. Here x plus 2 greater than or equal to also there, so that means minus 2 also we can substitute. Here x minus 3 greater than or equals to is 0 is there, so it means plus 3 also we can substitute. Now same like the previous one, minus infinity to minus 2. Minus infinity always open. Here minus 2 can be included because equal to is also there, so that's why closed union, because or is there. Here 3 can also included because here equal symbol is there, so 3 will be closed, comma union. This is the domain. Next, let us move to the question number 4. The function f of x is defined as f of x is equals to under root x minus alpha into beta minus x. Again, this is inside of the square root, so compulsory the value should be greater than or equals to 0 only. X minus alpha into beta minus x greater than or equals to 0. Let us separate it again. X minus alpha greater than or equals to 0, or beta minus x greater than or equals to 0. Here we can substitute alpha because greater than or equal is there. Here we can substitute beta also. So it means here alpha is included, beta is included. The domain will be alpha to beta, in between alpha to beta, as well as alpha and beta included, so closed. Next, fifth one. The function is defined by under root 2 minus x plus under root 1 plus x. So here two conditions should be there. It means it should satisfy both compulsory. Now if you observe the previous questions and these questions clearly, in the previous questions like these questions are there, that is 2 minus x into 1 plus x. So whenever we have into like this, we will keep or. But wherever we have plus minus symbols like this, compulsory and we need to use. Okay, let us check this one, how to solve now. Under root 2 minus x plus under root 1 plus x. This is inside of the square root. This is also inside of the square root. So both the values, inside value should be greater than or equals to 0 only compulsory. So it means 2 minus x should be greater than or equals to 0. And 1 plus x also should be greater than or equals to 0. Now minus x if we take another side, here plus x also if we take another side, this it will become 2 greater than or equals to x, and this 1 greater than or equals to minus x. Actually here x only there, but here minus x is there. Always we want plus x value only, not minus x. So for that what we will do, we will change the symbol. So minus x will become plus x. Whenever we are changing the positive to negative or negative to positive, that inequality symbol also will change. If it is less than means it will become greater than. If it is greater than means it will become less than. If it is less than or equal to, it becomes greater than or equal to. If it is greater than or equal, it becomes less than or equal. So now plus 1 will become minus 1. Greater than or equal to symbol will become less than or equals to, minus x will become plus x. Now observe these two statements clearly. Here 2 greater than or equals to x and minus 1 less than or equals to x. Both are having the condition and. So it means in these two, which numbers will be common? Only that numbers we need to take. So from these two we can write the condition as minus 1 less than or equals to x less than or equals to 2. So it means x lies from minus 1 to 2. Minus 1 and plus 2 both are included. Next, question number 6. Okay, the function is defined by sixth question. F of x is equals to under root x square minus 1 plus 1 divided by under root x square minus 3x plus 2. Under root x square minus 3x plus 2. Okay, now here this first one is inside of the square root. So the value should be greater than or equals to 0. Oh, I'm sorry, it is minus, not plus. Okay. X square minus 1 should be greater than or equals to 0. Here plus is there, so compulsory AND condition. This is in the denominator, so in the denominator 0 should not be there. So it means this inside value compulsory greater than 0 only. X square minus 3x plus 2 greater than 0. Okay, now if you observe here x square minus 1 can also be written as 1 square. So now this is x square minus 1 square. X square minus 1 square is in the form of x plus 1 into x minus 1. So this we can write it as a plus b into a minus b condition, greater than or equals to 0 again. And now this x square minus 3x plus 2 greater than 0, this is quadratic equation. This quadratic equation we need to simplify by splitting the middle term into two terms. Let us do that now. X square minus 3x plus 2, x square minus 3x plus 2. X square minus 3x can be written as minus 2x minus 1x plus 2 as it is. From the first and second condition terms I am taking x common, so we remains with x minus 2. Now third and fourth terms I am taking minus 1 common, then we remains with x minus 2. X minus 2 is 2 times, so write it once, and remaining is x minus 1. So x minus 2 into x minus 1 is greater than 0. That I will write in this place of x square minus 3x plus 2 greater than 0. That is x minus 1 into x minus 2 greater than 0. Anyway, this splitting is not necessary for us, so I am wrapping it. X minus 1 into x minus 2 greater than 0. Now observe here clearly. In the place of x, if I substitute minus 1, this total will become 0. In the place of x, if I substitute plus 1, this total will become 0. Now if you observe it, so minus 1 should be included. So it means from minus infinity to minus 1 closed. Here these two are multiplied, so union or OR union. Here again plus 1 is included, so 1 to infinity. And this one, if you observe here, x minus 1 is there, it means plus 1, x minus 2 is there, means plus 2. So minus infinity to plus 1 union 2 to infinity. Now in these two, if we observe what will be the common part, that is minus infinity to minus 1, minus infinity to minus 1, minus 1 closed, union 2 to infinity. Here actually less than or equal to symbol is not there. That's why we are not taking closed. Just we are going with the open only. Next, question number 7. 1 divided by under root mod x minus x, mod x minus x. Again the first thing, it is in the denominator, so compulsory it should be only greater than 0. Mod x minus x greater than 0. This minus x, if we take another side, root x greater than x. Now observe here clearly, root x and x, whatever the number you substitute in the place of x, always this mod x should be greater only. So which numbers you will substitute? That possibility is only negative numbers, because for example I am taking minus 2. In the place of x I am taking minus 2. So mod minus 2 is greater than minus 2. Mod minus 2 is nothing but plus 2. 2 is greater than minus 2. So it's correct statement. So I can substitute only negative. And what happens if we substitute positive? Let us check once then. I am substituting plus 3 now. Modulus 3 greater than 3. Modulus 3 is nothing but 3 only. 3 greater than 3. Obviously this statement is false. Next, let me check for 0. Modulus 0 greater than 0. Modulus 0 is nothing but 0 greater than 0. 0 greater than 0. This statement is also wrong. So I can conclude that only we can go with the negative numbers. So that can be written as minus infinity to 0. And 0 we should not include, that's why open bracket. Next, last question in this first bit. Question number 8. F of x is equals to under root mod x minus x. Modulus x minus x. Now here it is not in the denominator, it is just number only, so we can write greater than or equal to 0. Modulus x minus x greater than or equals to 0. Minus x, if we take another side, modulus x greater than or equals to plus x. Now here greater than or equal to symbol is there, so that's why any real number you can substitute. Any real number. Because from the previous one we got to know, if we substitute only negative numbers, this statement is correct. Mod x greater than x. But here we have equal symbol also, so that's why we can substitute 0 as well as we can substitute positive also. Negative numbers we can substitute, 0 we can substitute, positive we can substitute. So it means any real number we can substitute in the place of x. Then also that statement will be satisfied. Next, second bit is very easy bit. Let us move to the second bit now. In the second bit also again 10 questions are there. Just be patient. Function f is defined by, now in this case he gave ordered pairs, 4 comma 5, 5 comma 6, 6 comma minus 4. Actually in the exam also, whenever you will be having these kind of ordered pairs, that question will be very easy actually. And function g is defined by 4 comma minus 4, 6 comma 5, 8 comma 5. So whenever your professor or lecturer or any assistant professors or junior lecturers are explaining these domains, don't feel it as a boring topic, because understanding the domain concept is a little bit of difficult only. As you keep on practicing more number of questions, you feel definitely the topic as very easy. And sometimes we feel that the topic is very easy, but very silly mistakes we will do while writing the last step of the domain, while writing that, especially union, intersection, and which are common in that. So while writing that last step of the domain, we do mistakes sometimes. So be with patience and do more practice, then obviously that domains will be very easy work. And the same problem won't be there with the while writing range. Writing range is little bit easy than writing the domain. Only the problem with the domain only. Okay, now let's come to this question. Function f is defined by 4, 5, 5, 6, 6 minus 4, all ordered pairs, and function g is defined by 4, minus 4, 6, 5, and 8, 5. Then the first question is f plus g. So whenever we are doing two functions, when I'm speaking only if ordered pairs are given, like this 4 comma 5, 5 comma 6, like this, I'm speaking only when the ordered pairs are given. First check the common first term from both the functions. Here first term is 4, here also first term is 4. So it means we have some work with this ordered pair and this ordered pair. Next, here 5 is there, but in the second function 5 is not the first term, so we don't have any work with this. Next, third one, here the first one is 6, here also first one is 6, so we will be having work again with these two. Now next, g function, one more left, that is 8 comma 5. Here first term or first coordinate is 8, but whereas in the function f, 8 is not first coordinate, so we don't have any work with this 8 comma 5 also. Okay, now let us check how to solve this then. First question is f plus g. So simply open the brackets. While we are writing sets, which bracket we will do, that only curly bracket. Here 4 is there, so write it once only 4. Second terms, if they say plus, do plus. If they say minus, do minus. If they say product, do product. If they say division, do division. Now in this case it is a plus, so we need to add these two. Here 5 minus 4, 1. This is one ordered pair. Now next, here 6 is there, so write 6 only one time, comma, plus is there, so minus 4 plus 5, it is 1. So 4 comma 1 comma 6 comma 1, the value of f plus g. Next, one more question is there in this, that is f minus g also. F minus g. Second one, f minus g. Again same process here, 4 both are same, so write it once. 5 minus of minus 4, because in this case we are only doing subtraction, so 5 minus of minus 4 plus 4, so it will become 4 comma 4. Oh, I'm sorry, 5 minus of minus 4, right? 5 minus of minus 4 means 5 plus 4, 9. Next, 6 2 times is there, so write 6 one time as it is. Minus 4 minus 5 minus 9. We are doing subtraction, that's why I'm reading this as minus 5, so please don't get confused. So this is the value of f minus g now. Next, one more he is asking, that is 2f plus 4g. 2f plus 4g. First I will find the value of 2f first of all. So while writing this, with a constant, we need not to worry about the first coordinate at all. First coordinate 4 as it is, comma. Here 2 into f is there, so only second coordinate we need to multiply with 2. So 5 into 2, 10. So 4 comma 10 comma. Next, Now while doing this multiplication, I mean product with numbers, we need to take each and every ordered pair. In the previous steps we cancelled these two ordered pairs, right? But here in this case we need to consider those two also. So here 5 comma 6 is there, so 5 as it is, 6 2s are 12 comma last ordered pair. If we take 6 comma minus 4, 6 as it is, minus 4 2s are minus 8. So this is the ordered pair list of 2f. Next we want 4g also, so let us check the 4g. In this case also same, first numbers as it is. In the g 4 is there, 4 comma minus 4 is there, so 4 comma 4 into minus 4 minus 16. Next second one 6 comma 5 is there, so 6 comma 4 5s are 20. Next third one 8 comma 5 is there, 8 comma 4 5s are 20. So this is 2f and 4g. So now we need to find out 2f plus 4g value. So same like the previous one again. Here 4 is there, so write the 4 ones. 10 minus 16 minus 6, 4 comma minus 6. Here 6 is there, so write 6 ones. Minus 8 plus 20, 12, 6 comma 12. So the value of 2f plus 4g is nothing but f comma minus 6 comma 6 comma 12. Next one more question in this, that is f plus 4. Fourth one f plus 4. So it's very simple, writing the first one as it is, and for the second one we need to keep on adding 4. So now f we observe clearly here. F we have 4 comma 5. So 4 comma, for the second one we need to add 4, so 5 plus 4 9. Next second pair we have 5 comma 6, so 5 as it is, comma we need to add 4, 6 plus 4 10 comma. Next last ordered pair we have 6 comma minus 4, 6 comma, for minus 4 we need to add plus 4, minus 4 plus 4 0. So the ordered pairs for f plus 4 is 4 comma 9, 5 comma 10, 6 comma 0. Okay, next let us move to 5. This fifth one he gave fg. So it's very simple again. For clarity actually I am writing here again, because always I need to scroll up. So 4 comma 5, 5 comma 6, 6 comma minus 4. Next function g is defined by 4 comma minus 4, 6 comma 5 and 8 comma 5. Okay, now we want fg, so product just here 4 is there, so write 4 as it is. Now these two second numbers we need to multiply, 5 into minus 4 minus 20 comma, here 6 is there, so write 6 as it is, minus 4 into 5 minus 20. So fg is equals to 4 comma minus 20 comma 6 comma minus 20. Next let us move to the sixth one. F divided by g is there. So f divided by g is nothing but first one we need to write as it is, that is 4. Here if you observe clearly, this 4 as it is, and these two numbers we need to do division, that is 5 by minus 4, 4 comma 5 by minus 4. Next second numbers 6 as it is, minus 4 by 5, 6 comma minus 4 by 5. These are the order pairs for f by g. Next seventh one. For the second one we have modulus f. So in this case also same, first one as it is, Okay, what are the first ones? 4 comma 4 is there, 5 comma minus 4 is there. Oh, sorry, I need to go with only f, right? Okay, so f means 4 comma 5 is there, 4 comma 5. We are checking about mod f, so only check the second number. Plus 5 is there, so plus 5 is there means as it is you keep. Next, 5 comma 6 is there, 5 comma 6, second number is positive, so no problem. Next, comma, third one is 6 comma minus 4, 6 comma minus 4. Here modulus we want, so modulus means always the outcome will be positive only, so that's why remove minus 4 and keep plus 4. These are the ordered pairs of modulus f. Next, question number 8 in this, that is root f. Okay. First number 4 as usual, second number is 5, so apply root 5, comma, next pair 5 as it is, root 6, comma, 6 as it is, comma, under root minus 4. Now if we observe this clearly, inside of the square root negatives should not be there, so it means this third one is the not correct order pair. So we will remove that third one completely. We remains with 4 comma root 5 comma 5 comma root 6. Okay, next, ninth question we have squares, f square we have. So same again, first term as it is, second number we need to do squaring. First number is 4 as it is, second number is 5, 5 square 25, comma, in the second order pair first number is 5, comma, second number is 6, 6 square 36. In the third order pair first number is 6, comma, second number is minus 4, minus 4 square 16 again. Next, last question in this bit is cube, f cube. So first number as usual 4, comma, second number is 5, 5 cube 125. Next, first number is 5, second number is 6, 6 cube 216, comma, third pair first number is 6, second number is minus 4, minus 4 cube minus 64. Next, in this solved problems again third bit is there. So in the third bit he is asking both, that is finding the domain as well as range also. As I said previously, the most problem will be with the domains only. While writing the ranges it will become very easy. F of x is equals to 2 plus x divided by 2 minus x. Now if you observe, first I am writing domain. One side I will write domain and one side I will do range. Okay, now if you observe the denominator, it is 2 minus x. In the denominator 0 should not be there, because if 0 is there means it won't be defined. So that's why 2 minus x not equals to 0. So it means 2 not equals to x. Except 2, any other number is possible. So the domain will be r minus plus 2. Next, let us check the range. So for doing the finding the range, some methods will be there. In that, one of the method I am going to explain by finding the inverse of the function, because in the previous video also when I explained the inverse, one method I followed, the same method I am going to follow now also for finding the inverse. That is, first given polynomial function, make it equals to y. So we get y is equals to 2 plus x divided by 2 minus x. Total denominator take to the left side. Y into 2 minus x is equals to 2 plus x. Expand it. Y into 2, 2y minus y into x, xy is equals to 2 plus x. minus xy take to the right side and bring 2 to the left side. So 2y as it is plus 2 will become minus 2 is equals to x as it is minus xy will become plus xy. 2y minus 2 as it is equals to, from the right side if I take out x common, then we remains with 1 plus y. Take 1 plus y to the left side, then we get 2y minus 2 divided by 1 plus y is equals to x. This is just inverse. Now if we observe the denominator here the denominator is 1 plus y, so that 1 plus y should not be equals to 0 because it is in the denominator. So it means y should not be equals to minus 1. So the range means except minus 1 any other number we will get. So the range can be written as r minus 1. The domain is nothing but which number we can substitute. Range is nothing but which numbers we may get as the answers. So in this, whatever the number you substitute in the given function, except minus 1, remaining anything may occur. Next, second question in this. Actually in this third bit only 3 problems are there. So let us go with the second one now. F of x is equals to x divided by 1 plus x square. So first let me find the domain. So here also denominator is there. So denominator is there means denominator should not be equals to 0. Then 1 plus x square should not be equals to 0. So it means x square not equals to minus 1. X square not equals to minus 1. Observe this logic clearly. Any number if we do squaring, it may be positive number or it may be negative number or it may be neutral number, that is 0. For any number if you do squaring, answer will be compulsory positive only. There is no chance that we will get a negative number. So it means here not equals to minus 1 is saying already we know very well that minus won't come at all. So the domain will be total real number set. Next, let us move to finding the range. So for range, as it is first step, make the given function equals to y. Take the total denominator to that side. Then we will get x is equals to y times 1 plus x square. X is equals to y into 1 y plus y into x square, x square. Everything I'll take to the another side, I mean right side. Y x square as it is plus x will become minus x plus y equals to 0. Now if you observe this clearly, this is a quadratic equation. So to find the x value, what I will do, splitting middle term is not possible, so that's why I'm going to use the formula minus b plus or minus under root b square minus 4ac divided by 2a. Minus, as usual, what is the b value then? B is nothing but x coefficient. Here x coefficient is minus 1. So minus of minus 1 plus or minus under root b square. B value we know, minus 1 whole square minus 4 into a value. A is nothing but x square coefficient. Here it is y. Y into c constant, that is y again. Whole divided by 2 times a is nothing but y. Now if we simplify, minus of minus 1 plus 1 and plus or minus under root minus 1 whole square 1 minus 4 into y y square divided by 2y. So now if we observe clearly, this is inside of the square root and it is in the numerator, so it means greater than or equals to 0. 1 minus 4y square greater than or equals to 0. Here 1 can be written as 1 square. 1 square minus 4y square, that is nothing but a square minus b square formula. So 1 plus 2y into 1 minus 2y greater than or equals to 0. Here plus 1 is there, so our answer will be actually minus 1. Multiplied by 2 is there, so divided by 2. Here plus 1 is there, minus 1. Here multiplied by minus 2 is there, so divided by minus 2. It will cancel, it remains with 1 by 2. So the range will be from this number to this number, minus 1 by 2, comma 1 by 2. This is the range. It means from minus 1 by 2 to plus 1 by 2. Any number it may occur. Okay, let us move to the third problem in this bit. The function is defined by f of x is equals to under root 9 minus x square. Under root 9 minus x square. So here it is in the numerator only, not in the denominator. So it should be greater than or equals to 9 minus x square greater than or equals to 0. So 9 can be written as 3 square minus x square greater than or equals to 0. This is a square minus b square formula. So 3 plus x into 3 minus x greater than or equals to 0. Here plus 3 is there, so it will be minus 3. Here plus 3 is there. Again minus x is there, so it will become plus 3. So minus 3 plus 3 closed because it is greater than or equal to. So this is the domain. Now let us find the range of it. First take the function equals to y, that is y equals to under root 9 minus x square. Under root 9 minus x square. Now to remove this square, both the sides I will do squaring for the equation, so that here square root and square will get cancelled. Then we remains with y square is equals to 9 minus x square. I'll take everything one side now. Minus x square I'll bring to this side. It will become plus x square is equals to 9 minus y square. X we want, so x is equals to under root 9 minus y square. Again under root 9 minus y square is there, so it means this it is inside of the square root, so it means always greater than or equals to 0 only. Not under root, again inside number, right, only. So 9 minus y square should be greater than or equal to 0. So observe here clearly. In the place of y square, if I keep 9 minus 9, it will be exactly equals to 0. Y square is 9 means then y value will be only 3. So 3 is the maximum number I can substitute. Then what about the minimum number? First I will check any negatives are possible or not possible. I will take one negative number now. 9 as it is, minus as it is. In the place of y, I am substituting minus 1. minus 1 whole square. So s1 greater than or equals to 0. 9 minus 1, 8. 8 greater than or equals to 0. So 8 is not a perfect square, so which is not possible. So only 0 onwards it will be start then. So the range will be 0 to 3. Okay, let us move to the next topic. That next topic is even function and odd function. Even and odd function. If f of minus x is equals to f of x, then that function is called as even function. In case if f of minus x is equals to minus into f of x, that is called as odd function. That is odd function. So no need to worry about this all symbols and terminology, just very simple. In the place of x, if we substitute minus x, In this case we will substitute plus x. In this case we will substitute minus x. Both the answers should be same. Then it is called as even. In case if negative will come, that is called as odd function. So if we take one example, you will understand clearly now. For example, f of x is equals to x square is there. Shall we call this as even function? Let us check now. If f of minus x is equals to f of x, then we can say it is even. I am going to find now f of minus x value. So it means in the place of x we need to substitute minus x. In the place of x we need to substitute minus x whole square. Minus x whole square is nothing but x square only. So now if we observe the answers clearly, f of x value is x square. F of minus x value also x square only. So f of x equals to f of minus x. Then we can say that this is even function. Next. Function g of x is defined by cos x. Is it even function or odd function? Let us check once. I am going to take g of minus x now. Cos of, in the place of x, minus x. Cos of minus x is nothing but cos x again. G of x also cos x only. G of minus x also cos x only. So g of x is equals to g of minus x. Then this is also even function. Next. Modulus x. Function h of x is defined by modulus or mod x. Let us check. H of minus x I am taking. So in the place of x we need to substitute minus x. Modulus minus x. Modulus minus x is plus x. Mod x is nothing but plus x. So h of x value is plus x only. H of minus x also plus x only. So this is also an even function. Next. What about this function then? F of x is equals to x. Is it even or odd function? Obviously odd function only, because f of x is x. Then what about f of minus x? Minus x. So f of minus x is equals to minus f of x. Then that kind of function is odd function. Then what about one more function? That is trigonometry ratio tan x. Function g of x is defined by tan x. Is it even function or odd function? Let us check once. G of minus x is equals to tan of, in the place of x, minus x. Tan of minus x minus tan x. So here g of x is tan x and g of minus x is minus tan x. So this is odd function. Now what happens if we add one odd function and one even function then? For example, f of x is equals to cos x plus tan x. Cos x is an even function, whereas tan x is an odd function. Then these are neither even nor odd functions. Of course, separate name is not there, just like that, that's it. Okay, next. Before going to the next topic, let's have a small discussion about polynomials. What is a polynomial actually? An expression with non-negative integral power. I repeat, an expression with non-negative integral power. Non-negative integral power. An expression with non-negative integral power is called as a polynomial. So in simple words we can say that for any alphabet, if the power is a whole number, then that particular expression is called as a polynomial. For example, x power 2 is there. For alphabet, power is 2. 2 is a whole number, so this is a polynomial. For example, x power 5 plus 7, x power 6 plus 2 is there. Here power 5 is a whole number, power 6 is a whole number. Here power only not there, so no problem at all. This is also a polynomial. Now let me check one more. X power minus 3. Here power minus 3 is not a whole number, so this is not a polynomial at all. Why I am saying about this polynomial means one more type of function we have, that is polynomial function. Now any function, if it is a polynomial, for example ax plus b is there, for x power is not there means 1 is there, so 1 is a whole number. This is called as a polynomial function. Let us check. Minus 7x power 4 plus 3x square plus 2. Is it a polynomial function? Obviously, because power 4 whole number, power 2 whole number, here power x only not there, so no problem. So all the powers are whole numbers, so this is a polynomial. Then if we define this with some g of x or h of x, something like this, then we can say this is a polynomial function. Now if I write two polynomial functions in the form of p by q, for example one polynomial function x square minus 3x plus 2 and one more polynomial function x square plus 1. If I write one polynomial function in the numerator and one polynomial function in the denominator, that type of functions are called as rational function. Rational function. Then polynomials definition we got clearly. Sir, then what if happens with this kind of functions then? Those kind of functions are nothing but algebraic functions. Those kind of functions are algebraic functions. Next, again one more, we have solved problems in the page number 31. Let us have a discuss about that. In this only 3 bits are there, but in every bit many questions are there. Okay, let us finish it. Solved problems in the page number 31. Okay, the first question. F of x is defined by x square and g of x is defined by modulus x. Now based on these two functions he is asking some questions. In that the first question is f plus g. In the previous bits we did f plus g, f minus g, f g like this only, but in that case those are ordered pairs, whereas here just normal polynomial kind of functions. So now how to do this? It's very simple, just adding the functions both. F is x square plus g is modulus x. X square plus modulus x. Then here modulus x is there, so modulus x is there means compulsory every positive number will become a, every negative number will become a positive number only. 0 means 0 only, every positive will become positive only. So based on that, if x value is greater than or equals to 0, then what will be this value? As it is x square plus x. If in case x value is less than 0, then that value will become x square minus x. So whenever we are writing this condition, we should be very careful, because we know very well modulus x is nothing but a positive number. Then why we are getting a negative here? I mentioned here clearly x is less than 0. X is less than 0 means a negative number. If I substitute that negative number in the place of x, negative into negative, positive again. So this you need to keep it in mind. Now second question in this, we have just that is f minus g now. Second question, f minus g. So f we have x square minus g we have modulus x. Two conditions as usual, if x greater than or equals to 0, and one more is if x less than 0. So now here minus is there, then x greater than or equals to 0 will become x square minus x. If x less than 0 will become x square plus x. Next, third one, product is there, fg. This same fg also can be written as fg of x. Fg of x is nothing but f of x into g of x. Now f of x we know very well, that is x square. G of x is modulus x. X square into modulus x. Again two conditions. If x is greater than or equals to 0 and if x less than 0. So x, if it is greater than or equals to 0, then value will be x cube. In case if x is less than 0, then it will become minus x cube. Next, fourth question. What is the value of 2f? So 2f is the same as 2f into x. This is the same as 2 times f of x. So 2 times f of x is nothing but x square. So 2 into x square, that is 2x square. Next, fifth one. Here we have f square. F square is the same as f square of x. That is the same as f of x whole square. So f of x value is given as x square whole square. X square whole square is nothing but x power 4. Next, last, sixth one is f plus 3. Sixth one, f plus 3. F plus 3 is nothing but f plus 3 of x. That is nothing but f of x plus constant as usual. F of x value we know clearly from the question, x square plus 3 as it is. Now in the second bit of this solved problems, they gave some functions and they are asking whether that function is even function or odd function. So in that first question is given as f of x is defined by a power x minus a power minus x plus sin x. He is asking whether it is even function or odd function. Let us check. So f of x is given as usual. Now I am going to substitute f of minus x. Sorry, in the place of x, minus x. A, here x is there, so minus x minus a. Already minus is there, so as it is. Again in the place of x, minus x plus sine of minus x, which is equals to a power minus x minus a times minus into minus x plus, sorry, plus won't come because sine of minus x is minus sine x. Now what I will do, from all these three terms I will take out minus common. If I take out minus common, a power minus x will become minus a power minus x, minus a power x will become plus a power x, minus sin x will become plus sin x. Now observe the value of f of x as well as f of minus x. In the f of x, a power x is there. Here also a power x is there. Here minus a power minus x minus a power minus x plus sin x plus sin x. So is equals to minus as usual f of x. F of minus x is equals to minus f of x. Then this is odd function. Next, second question in this. F of x function is defined by f of x is equals to x times e power x minus 1 divided by e power x plus 1. F of x is already given in the question, so I am going to deal with f of minus x times e power minus x minus 1 by e power minus x plus 1. minus x as it is times e power minus x is nothing but 1 by e power x minus 1 by e power minus x 1 by e power x plus 1 minus x as it is 1 minus e power x into 1 e power x by e power x divided by 1 plus e power x into 1 e power x by e power x. Here both e power x will get cancelled, then we remains with minus x times 1 minus e power x by 1 plus e power x. So what I will do, I will write the outside term minus x as it is. From the numerator I will take out minus common. So if I take out minus common, plus 1 will become minus 1, minus e power x will become plus e power x whole divided by 1 plus e power x. Now here we have one minus symbol, here also minus symbol is there, so minus into minus it will become plus. So we remains with e power x minus 1 divided by e power x plus 1. Now if we observe the f of x value as well as this value, both are same. So this is even function. Next, third question in this. Third question. Function f of x is equals to log of x plus under root x square 1. Sorry, under root x square plus 1. Now I am going to find f of minus x value. F of minus x is equals to log of, in the place of x, minus x plus under root again in the place of x minus x whole square plus 1. So we get log of minus x plus under root minus x whole square x square plus 1. Now what I will do is log of minus x plus under root x square plus 1. I will multiply and divide this by x plus under root x square plus 1. X plus under root x square plus 1 divided by x plus under root x square plus 1. This is a minus b, a plus b. A minus b into a plus b formula will be there in the numerator. So we can write it as a square minus b square. That is x square plus 1 whole square minus x square divided by x plus under root x square plus 1. Oh sorry, I forgot writing logarithm. Here, sorry, under root, right? These two will get cancelled. So we remains with x square plus 1 minus x square divided by x plus under root x square plus 1. Here x square will get cancelled. Sorry, I forget again logarithm. Log 1 by x plus under root x square plus 1. Log as it is 1 by, there means we can write it as x plus under root x square plus 1 whole power minus 1. This power minus 1 will come to the front, so we remains with minus 1, otherwise simply minus log of x plus under root x square plus 1. This log of x plus under root x square plus 1 is nothing but f of x, that is given question only. So this will be minus f of x. F of x value equals to minus f of x, then this function will become odd function. Okay, next in this solved problems, bit number 3. Finding the domains. It's very easy questions. Okay, the first problem is f of x is equals to f of x is equals to 1 by under root absolute x square minus absolute x minus 2. Now this is in the denominator as well as inside of the square root, so it should be only greater than 2. X square minus x minus 2 should be greater than 0. Again, by splitting the middle term into 2 terms, we will going to solve it. X square minus x, I will write it as minus 2x plus 1x minus 2, as it is greater than 0. From the first and second term, I will take out x common. Then we remains with x minus 2. From the third and fourth term, I will take out plus 1 common. Then, sorry, not this one. Then we remains with x minus 2 greater than 0. Here x minus 2 is there 2 times, so write it once. X minus 2 times x plus 1, it is greater than 0. Now x minus 2 greater than 0, or sorry, x plus 1 greater than 0. This minus 2, if we take another side, x greater than 2, this one will become x less than minus 1. X greater than 2 or x less than minus 1. So then what we can write from these two? X greater than 2. So it means starting from 3 onwards, 3 to infinity. So 3 we can include, because only 2 we should not include, so it means 3 we can include. Union x less than minus 1. So it means minus infinity to minus 1. Here only less than is there, so that's why minus 1 should not be included. So this only I will write it in reverse. Minus infinity comma minus 1 union 3 comma infinity. This is the domain. Next, second question. F of x is equals to log of x minus absolute x. Now here logarithm is there, so logarithm value should be always greater than 0 only. So x minus x should be compulsory greater than 0. It means x should be greater than 0. Sorry, x should be greater than x. X should be greater than x means compulsory x should not be a negative number. X should not be a negative number. So it means real numbers minus integer. From the real numbers, if we subtract the integers, then for remaining all it will become. Next, third one in this. The question is f of x is equals to under root log 3 minus x base x. Sorry, 3 minus x divided by x with the base 10. Here completely log is inside of the square root, so it means total value should be greater than or equals to 0. Log 3 minus x divided x with the base 10 is greater than or equals to 0, and log value should be always greater than 0. So that's why 3 minus x by x value alone should be greater than 0. Now this is logarithmic form. I will convert this to exponential form. Then it will become 3 minus x divided by x greater than or equals to 10 power 0. And here it will become 3 minus x should be greater than 0, as well as x also should be greater than 0. Then only this total condition will be satisfied. So now this 3 minus x divided by x greater than or equals to 10 power 0 is nothing but 1, and 3 minus x greater than 0 and x should be greater than 0 means those numbers should be between 0 to 3. Between 0 to 3 only. So 0, 3 both should be opened. Next, this x I will take to the right side, then it will become 3 minus x greater than or equals to x. And this is 0, 3 as usual. 3 minus x greater than or equals to x. Then I will do minus x to another side. Then we will get 3 greater than or equals to x plus x. That is nothing but 3 greater than or equals to 2x. Then we want x value. So x should be less than or equals to 3 by 2. And this is 0, 3 as usual. X less than or equals to 3 by 2 and 0, 3. So in between these two common we need to pick it out because it is and is nothing but intersection like. So 0 it will be opened to 3, 2. Here 3, 2 equal symbol is there, so that's why 3, 2 will be closed. So the domain will be 0, 3 by 2, 3 by 2 closed. Next, question number 4. Function is defined by f of x is equals to under root x plus 2 plus 1 divided by log 1 minus x base 10. Okay, now here x plus 2 is inside of the square root, so that is only alone number, not in the denominator. So it means x plus 2 should be greater than or equals to 0. Plus is there, so that's why. And here 1 minus x compulsory should be greater than 0 only. And one more should be there. Here 1 minus x is there. In case if I substitute 1 in the place of x, it will become log 1 minus 1 base 10, log 0 base 10. Log 0 is not defined. So x value should not be 1 also. And x not equals to 1. So total these three conditions it should satisfy. X plus 2 greater than or equals to 0 is nothing but x greater than or equals to minus 2. And 1 minus x greater than 0 is nothing but 1 greater than x. And x not equals to 0. Now, if we observe all these three clearly, x greater than or equals to minus 2 and 1 greater than x. So here 1 greater than x. So it means 1 should be closed till minus 2. Minus 2 here it is less than or equal to, so closed. Minus 2, 1 closed. Then x should not be equals to 0. So from this we need to subtract 0. So the domain will be minus 2 comma 1 minus 2 closed minus 0. Next, last question in this bit. Function f of x is defined by under root 3 plus x plus under root 3 minus x whole divided by x. Under root 3 plus x is in the numerator. So 3 plus x should not be 3 plus x greater than or equals to 0. Plus is there, so and again 3 minus x is also in the numerator only and it is under root. So 3 minus x also greater than or equals to 0. And x is in the denominator, so in the denominator it should not be equals to 0. So whatever we are writing, it should satisfy all these three conditions. If we observe this one and this one clearly, 3 plus x greater than or equals to 0 and 3 minus x greater than or equals to 0. So it means it lies from minus 3 to plus 3. So minus 3 less than or equals to x less than or equals to plus 3. And x not equals to 0. So minus 3 less than or equals to x less than or equals to 3 means minus 3 comma 3 both closed. From this we need to subtract 0. This is the domain. So by this we completed all the solved problems. In the next video I will explain exercise 1 of 3. Till now if you didn't subscribe to my channel, subscribe for more videos. Thank you.